let's start with the, I will try to put this, everything. Let's start with the second part. Now that you all have a persistent identifier of your own, you know what it is, you know that you can add your own metadata, right? We created, most of you created a persistent identifier with metadata, a URL, a description, and a title. So now that you are a PID owner, let's see what we're going to see in the next slides. In the session, the second part of the persistent identifier presentation. So the second part, we have split it in 4 different parts and a small game with questions about what we have discussed today. The first one is chaos, different types of persistent identifiers and which one to use. You are not alone. There are a number of project organizations and services that exist out there that understand that the researchers have a problem and want tools and services and ideas, policies, and everything you need to use and create your persistent identifier. Big picture, it's the PID graph, how they are all connected between them. And some use cases and success stories, and the questionnaire game, let's say, that I told you earlier. So now that we know what a persistent identifier is, let's see which are the different types of the persistent identifiers and which of them we can use in the different in our daily work, research, or whatever each of us is doing. Earlier, we were discussing what a persistent identifier is. Identifiers have been used in the digital era since lots of years now. There exist a various system of identifiers exist. You all know of some identifiers. You have an ID, you have see the identifier that the books are using, DOIs that we said earlier. All of you have ORCIDs. All of them have a common goal to be unique, citable, actionable, and easy to use by everyone. And if I could ask you now, which are the main persistent identifiers you know, or not only persistent identifiers you know? Which is the first thing that comes in your mind when you are hearing about identifiers?
We can see these pictures.
You can say from this picture. It's a hint to help you to make a discussion.
Social security number.
Okay. Other? I can put you can copy one of them, I don't have a problem.
Yeah, barcode on products.
Yes, exactly. Okay, so IDs, passport, yeah. So we all have an identifier in our life. We are using it. Now we want to put this in our work. So if let's say that I would ask you what type of identifiers you think there exist, the answer is that we have identifiers for people, for organizations, for places, organization, and for things, it's data sets, it's what else do instruments, objects, right? We have different types of things. And we will start with the people. The first one, but that's, I think someone said that he has an orchid, right? He's watching something else, I can see him. Who has an orchid? Oh. What do you put in an orchid?
Publication, articles.
So it's a unique ID, a persistent identifier that you use that has records with information about what you do in your work, right? It has, what else? Include employment, education, research output, publications, whatever it has to do with your work, right? It's one of the first identifiers that were used for people. And we can say the motto they have is distinguish yourself. So you put there all the information that has to do with your daily work. It's a persistent identifier. You own, you control, you update, you add the necessary information, and it has records connected, as already said, to employment, education, research output. It offers also APIs that provide access to the records and allows you to update the information every now and then. Another ID that is used for people is the researcher ID. It's a different. It's for people. It's again for people. The idea is that it wants to identify. It's a system for scientific authors. You can put again there your information about your publication, and what it does, it allows you to create an online profile to showcase your publication history. You can find it online. I have an example here. And it also has some metrics where you can see the number of indexing, the publication in the Web Science, and other statistics about your publications. Apart from the persistent identifiers for people, we also have the persistent identifier for organizations. Organizations like people are not static entities. They change their names sometimes. They merge. They split, they shut down. So all this information has to be depicted somewhere so that you know what is happening now for this organization. One type of persistent identifier that is used for organization is the Research Organization Registry, known as ROR ID. And again, it's referred to an organization. It makes it easy for anyone or for any system to find information about organization and to connect research organization to researchers and research outputs. It is used in publishing systems, in repositories, in funder, grant management platforms, open access workflows, and everywhere that you want to use a persistent identifier for organization. Again, it also has a service, an API, that provides access to the records and that can easily be displayed wherever you want. This is the type of information, the list of the information that you can see from an organization, and has also lots of information that you can see, if it is offered by the organization, of course. Apart from ROR, in the organizational level, persistent identifiers, we have the Wikidata, which you can have Wikidata uses IDs for internal description of the organizations, but also for external use. And the ISNI, which is the International Standard Name Identifier, which is used for organizations. It is an ISO standard used from libraries, publisher databases, and other organizations. So we have a number of different types of persistent identifiers we can use for organization. But the last one, which is the different types for things, it has how many different persistent identifiers? I can still find more persistent identifiers. We tried here in the next few slides to depict a part of the persistent identifier we know, and they are commonly used by the systems and researchers. So the first one is the handle system, and via the B2 handle service that we showed earlier. It's the persistent identifiers that are created used by EUDAT. You can use the handle persistent identifiers in all the stages of research, right? From the beginning, from raw data, from intermediate outputs, wherever you want. It's not a problem. It enables FAIR principles, the FAIR ones that we discussed earlier, findable, accessible, interoperable, and reusable. It enables persistency, and it supports for the end user an online service, a REST API, and a library, a Python library that can be easily used by everyone. For the communities, it supports a number of services like the prefix, the perfect hosting, to help me support build the community software, create your own PID record that fits your needs. You can create a number of metadata for your PID in the handle system, and searching and reverse lookup mechanism, so that you can search in the metadata of the PID in B2 handle and find what you want. Other types of persistent identifiers and well known are the DOIs, and one of the services that is used is the data side DOIs. And registering the DOIs makes the outputs more discoverable. It has support, it has services that make easier for you to follow the best practices. It makes research data management easy. You can register your persistent identifier in less than 1 minute. I have also created a Postman if you want to see later, if you have time, or in another session, I don't know, how to register your own DOIs. I have two Postman files for the environment and the actions you can do if you want to have a look later. It has a big community, so if you have a problem, it can easily be solved by discussing this in the community. And it has services that help you track and report on your research. It has statistics, reports, and it is support data citation and usage analytics. Apart from this, there is also the Crossref DOI, which is the Crossref organization, which interlinks millions of items. I think also Tibor said a few things about the Crossref, right? And the idea of the Crossref is that they found the solution to a problem. The problem was that finding bodies couldn't easily track the published output of a funding. The publishers couldn't easily report which articles result from research supported by specific funders or grants. So when we hear about Crossref, we usually say that it's the funder ID, the funder registry, and the grant ID, where you can, which is a standard way of reporting funding sources for published research. And one other persistent identifier is the software heritage persistent identifier. One of the ambitions of software heritage is to collect, preserve, and share all the software that is publicly available in source code. So they create persistent identifiers for the source code itself and the releases it may have in the next years, let's say. So we have here persistent identifiers for software, another data set of, and then in this slide we are trying to, let's say, distinguish where to use what type of persistent identifier. For example, for datasets, we use what is commonly used is the URN-NBN, which is the national persistent identifiers based on the uniform resource name. It is usually based. It is used by the National Library, right? And it is based on the national number they are using in the libraries. The DOIs that we have already discussed from the different organizations, one from the different agencies, let's say, it's the data site, for example, and the handle system, which is also the one that we're using in EUDAT. For the publication things, let's say, the identifiers we're using is the archive, which is an open access repository for preprints, known as ePrints. So what we do via the archive identifier is mine an identifier for each imprint. You can find it for all the different types of persistent identifier we present here. You can find an example so that you can see how it is used, the type of the naming conventions they are using, and what where they're referring to. Another persistent identifier for the publication is the ISSN, which is the International Standard Serial Number. I think we said at the beginning. And the Crossref DOI, where it's again where you can assign DOIs to the different items, and of course the funder ID and the grant ID. For the publication, we also have the Wikidata item, the ISBN, and the handle system. You can see from the presentation that The handlers can be used in all the different types of things, publication, datasets, outputs, whatever you want, you can assign a handle. Tibor?
I need your mic. I need your mic.
Sorry. You have to stand up.
So I hope you can hear me. This slide is just to show a kind of a new emerging type of PID. So an emerging trend is that people identify and reference their instruments, their scientific instruments, which means if scientific data is created by instruments, then they can really point to a dedicated instrument. This was the instrument which created the scientific data. This is just to show the landing page of the B2INST service, which is provided by EUDAT to identify, to create persistent identifier for instruments. So what is on the landing page? There are some generic stuff like name of the instruments or description of the instruments, and of course the identifier which was created for the instruments. And there are more specific attributes, metadata attributes, which are registered for the instrument. EUDAT was not deciding on how the metadata looks like, because there are other experts who know more about how to describe instruments. So in the RDA, in the Research Data Alliance, a small working group was created, a dedicated schema which can be used to describe instruments, and EUDAT just took this result of the discussion of experts, and this is what is provided by the service. So what kind of best practices exist with the different kind of identifiers? Yeah, the basic idea here that if you use identifiers, you should try to link them together. What does it mean? You've discussed the ORCID idea. If you have an ORCID ID, link this ORCID ID with the persistent identifier of your published scientific articles, for example. Or if you have an article, scientific article based on data sets, so your scientific results are based on data sets, what you used. Don't just write a paragraph, I use data sets which I created, but it's a best practice to put the PID of all used data sets, so others can directly find these data sets and will have a direct relation to all these kind of data sets. There are other IDs, they can be all linked together. I won't go into details, but say some words about, thank you, but say some words about the research lifecycle. Actually, a lot has been written about how an ideal research lifecycle and research data lifecycle looks like. I won't judge which of these descriptions is the best. This is a very, very generic figure on the research lifecycle. What I would like to mention here, that ideally persistent identifiers are used in each phase of the research life cycle, and ideally these persistent identifiers are shared in every phase of the research life cycle. Coming to EUDAT again, EUDAT follows the research life cycle and supports the research life cycle with different services, and basically many of the B2 services make use of different kind of and different type of persistent identifiers. A side note was mentioned here that B2Handle is such a generic PID service that B2Handle PIDs can be used in each phase and in each services, each other B2 services. With that, so we saw that quite some types of different PIDs exist. The question is what to do with them, because these different PID services, you always need to know what kind of PID you are dealing with, and you always need to know to which resolver you need to go to have your PID resolved, and if you need the metadata stored in the PID, which resolver is to use. The good news is there are more and more help available for this kind of thing. Is one solution which is being implemented now in one of the EOSC projects is the so-called meta resolver. This will provide you a unique interface, a uniform interface which allows different kind of PIDs to be resolved at one dedicated point and at one dedicated place. With that, I'm handing back to Temis.
I think we can have 3 minutes to discuss with all of you the different types of identifiers, what you use and what you would like to learn more to start using it, I mean. Who wants to say something?
So,
Yeah.
for example, I submit article and I want to publish it in the database, but I don't know how to do it.
So let's write it here. Article. Right. You want an article? And you want to add?
To publish in the database that I use.
I will write data, right? Right. You want to publish somewhere the data. Based on what we said, what can you use? What is the best solution? Maybe we can go back to the different types.
So probably a comment here. In ideal case, you as a person who submit all these things doesn't need to do anything with the PIDs, because the systems where you submit
Yeah,
your
let's
stuff
say that
will
we.
deal with the PIDs. So if you submit an article to an electronic journal, then the journal will assign a persistent identifier for
Let's say that you don't have something and you have to say that I have an article and I want to publish again my data. Which types of persistent identifiers can we use from what we said earlier? And of course you have an ORCID, right? You said you have an ORCID, right?
Yeah.
What do you propose? Someone else? Okay, DOI. For the article?
And also, you can use it for the database.
Okay, so you say you're proposing DOI and DOI.
In Indonesia, we also use handle for article and data, but in practice, when I want to link this with reference management system, I can't import the handle like the OI using that. So that is still in progress. Or
So you are using handle, right?
Can I take this question?
Yes.
Yeah, so the idea, so DOIs are also handles, but this is a kind of a well-branded handle with very strict rules how metadata in handle in DOIs should look like. There are also different kind of DOIs, data side DOIs, cross-ref DOIs, DOIs for movie and media stuffs, DOIs for some other things. What works quite well is that some of the external systems understand this particular DOI metadata format. So if you register a DOI, when you register and assign a DOI, the one who does this need to fill out these metadata fields. And these external systems understand exactly that metadata schema. They can start with the processing the metadata which is in the schema. If you use other systems, like the generic vendor system, you have much more freedom what kind of metadata you can put in it. And there is a layer in between where you need to say somewhere, somehow, how to deal, what you store in the PID record or what you store in an external metadata record.
So actually,
this is the missing link
between them,
which gives you other way around, which doesn't give you a ready-made solution how to import everything from a generic handle, but it gives you the freedom to import everything you want. You just need this missing part, which
it's so small.
yeah, and this tiny little thing can be a huge work, depending on what is it. We will have a slide about a project which works on typing, PIDs typing datasets, and they are aiming to provide.
You mean to assign data types to data, to data? Okay, so this is both are correct, right?
Right.
The difference, as you already mentioned, is that in DOI you have strict metadata, right? In the handle system, you can create your own metadata. But at the bottom, they use the same technology. They are both handles. That's what Tibor told you. And do you want to add anything else? Is anyone else writing the article with you? A co-author, so that we can assign a persistent identifier to your co-author? For example, you have an article, there are 3 authors, so you can use their ORCID ID, right? Or the researcher ID, whatever you want. Maybe we can add, what else can we add? The organization. Yeah. So we can use this type of persistent, different types of persistent identifier, let's say ROR, for example. What else did you say? Sorry?
Funders.
Funder, if it's funded. So from a simple article with that you use data to create, you create all these different links. And now you have enriched the document with information and can be easily findable from other sources. With just using the persistent identifiers of the different types in the article. You usually write, you always have a co-author and an organization, so if you add them, you could create links with the organization and the other authors, right? So little steps, small steps can create new links. What is the next one?
The next one is you are not alone.
You are not alone, yes. You are not alone. Now that we have described all the different persistent identifiers, what we can do with the persistent identifiers, the different systems that they are using, the different technologies that we are using, we thought, we discussed it with Tibor and we said that maybe we should add a small some description and information about what is going on right now in this ecosystem, the projects, the policies, the countries, the organizations, and some forums. So currently, they're running two big projects that are running about the persistent identifiers. The first one is the FAIR Core for EOSC, and the other is the FAIR Impact. I think the one is helping the other to finalize its job. I mean, the first one has to do with technology, and the second one mainly for, again for technology, but for policies and examples. The challenge that the first one I'm referring to, the FAIR core for EOSC, has to do is to create, not only develop, but add functionalities to already existing services, right? Develop new services and add functionalities to already existing services that have to do with identifiers and introducing new resource types and machine actionable persistent identifiers. Metadata and ontologies, interoperability issues, and the software heritage that we said, the research software, where you can automatically deposit the software you are using and the new releases into the repository of software heritage. These are the services that are the groups in the FAIR core for EOSC are working on. It's the EOSC Research Discovery Graph. Tibor will tell you a few words about the graphs in the PID ecosystem. The PID graph, the metadata schema and crosswork registry, it's to support discovery and access to metadata schemas. The data type registry, again, we're going to see a few things about the data types in the next slides. It's the data type registry to provide friendly APIs for metadata imports and access to different data types. The PID meta resolver, it's the slide we saw earlier. Compliance toolkit, so that you can see if you comply and you use the steps that is in the EOSC PID policy. The EOSC research identifier services to mine PIDs for research projects, allowing to manage and track activities. The research software APIs and connectors, a set of connectors that can easily be used from other communities, and the software heritage mirror that we saw earlier for the software of the EOSC. The case studies they are using in order to validate the work that is being done. The idea is it's in the development and in the deployment of the services. Some people from different domain-specific communities are participating, like climate change, European integration of national level services, mathematics, social science and humanities, and research data communities. At the same time, the FAIR, if you want more information about the project and the services, you can find it from here. And at the same time, we have the FAIR Impact Project, which is a complementary project about persistent identifiers. And what they have to do is to support the implementation of FAIR-enabled practices across specific communities and research outputs at all the different types of levels, the European, national, and institutional level. They want to support all the people working in these different levels to understand and use and implement the correct practices of the persistent identifiers. The how is that in the implementation of the practices, they engage a wide range of stakeholders. They are trying to identify current and emerging FAIR enabling components, practices, policies, ideas, tools, technical specs, everything that can help you understand how the persistent identifier works and how you can use them. They also have a number of available solutions from specific communities, and they want to translate them and make them work in other communities and in other domains. In order to support all this work, they want to take the next step in implementing and defining the support, governance, and the coordination mechanism for these services. The communities and they are using and they're participating in this project are mainly from the agri-food, the life science, the photoneutron science, and the social science and humanities. Since these two projects are complementary, there is a technical bridging team. So when you find a solution that fits a domain, they are trying to see if you can use it in some services they implement in the FAIR core for EOSC. And I think that some of the work that will be done in the FAIR impact will be implemented as an example in the FAIR Core for EOSC project. That's all for the projects.
So we are changing again. Let's continue with some organizations which are definitely more than, or the focus of these organizations are definitely more than just PIDs. I name here exemplary EUDAT and EOSC, the European Open Science Cloud. Who has never heard anything about the European Open Science Cloud? Okay, yeah, so the European Open Science Cloud is kind of a flagship initiative to support science in Europe and beyond. And what you see on the slides is the architecture of the European Open Science Cloud. The important thing here is that you probably don't see the details, but what is marked with red circles is a kind of PID-related activities in the European Open Science Cloud, because EOSC recognized the importance and the role of persistent identifiers. Just to give you some examples, on the bottom there is the core platform of EOSC is depicted, PID-related services, and the usage of PIDs in services is part of the core services. On the middle, you see the coordination, the core coordination activities. In EOSC, there are around 20 task forces dedicated for different topics. One of them is dedicated for the PID policy and implementation. And more on this task force I have on the next slide. The task force has about 20 members. This is a well-balanced group of users, PID users, a well-balanced use of PID experts, including the technology experts and including the domain experts. And we have also some PID providers in this task force, and 2 observers for the European Commission. I won't go into the details of what the task force is doing, probably just highlight 4 subgroups, because they will publish some reports which might be of interest. The first focus group tried to map the PID-related activities in the European landscape, more precisely in the EOSC context. This is basically a list of known PID activities around EOSC projects. Another focus group was try to collect community-specific perspectives. A report, a draft report is ready. If you are interested, you can have this report and you can read the details. Another working group or focus group works on the harmonization of the various PID vocabularies out there, because it was found that different initiatives, different EOSC-related projects, different players in the PID ecosystem use similar but slightly different vocabularies for PID-related activities. So harmonizing all of these vocabularies might be very useful for the broader community. And the last focus group at the moment try to make the PID policy more readable and provide concrete examples what things were written down in the PID policy really mean in real life. If you need more info about the task force, the co-chairs are very nice guys. You can contact the co-chairs anytime, and they will give you more insights.
because it's him and me. That's why.
Yeah. The next slide is. So why this slide? Out there are 4 acknowledged world data organizations, and there is a 5th one, an emerging one. This is the Fair Digital Objects Forum. If you had such issues, that you have different, what we discussed earlier, that you have different information about your entities, and you would like to bring all this information somehow together, then one of the possible solutions is the Fair Digital Object as such. If you would like to know more about the Fair Digital Objects, the Fair Digital Object Forum published some specification about how an ideal fair digital object should look like, how frameworks around fair digital objects should look like. The main goal is to have that kind of information machine actionable. So not just for humans who are reading the articles, but also for machines who try to process that kind of links, that kind of metadata. Coming to the big picture, how to bring everything together. I will show some examples how the data in the PIDs can be used and what kind of extra services can be set up with the help of persistent identifiers. So yeah, a buzzword in this context is the persistent identifier graph or PID graph. This is actually a very generic idea which describes how to recognize relationships with the help of PIDs and how to perform kind of network analysis with the help of PIDs. So there are now quite some brandings for PID graphs, like the, sorry, I don't see my slides. So like the PID graph or the open science graph or the research graph or the scientific graph or the knowledge graph or research knowledge graph or open knowledge research graph or some others. And maybe there are also other ones I am not aware of it. The branding PID graph is now being promoted and used by DataCite as an organization. And just let me show an example on the next slides. Yeah, this one, yeah. So an example how a PID graph could look like. The best known examples are about analyzing some networks or kind of aggregations, are also very typical use cases. In the specific example on the left, an organization assigned a persistent identifier to everything related to the research lifecycle and research workflows. So all the research articles got PIDs, or the data sets used in the research articles got PIDs, or the scientific devices they used to create that kind of research data got persistent identifiers. And now they want to know how useful a particular scientific device was to lead to research results, concrete research results. In this case, the device was a small, tiny sensor, and the sensor generated some data. Data was used for publications, and publications have impact. That's the basic idea behind this network analysis. And the query is how much impact that particular sensor in the middle generated. I do not want to discuss how impact is calculated and what impact means. There are related literature which discusses this. But from the PID graph point of view, the question is, which scientific publications exist. These are the scientific publications exist, which are related to data sets, which data sets were created by these particular sensors. So this is a kind of a visualization of that kind of network analysis. You will have a similar example on Thursday in the complex data workflow analysis session, where a colleague of mine will refine this kind of example for you. The example on the right is an aggregation coming from data side. It's a bit older, but it shows the number of resources and links in the PID graph was available that time, 2020, in the data side graph API. For all these examples are somehow important that the PIDs are somehow standardized. So what is in the PID is somehow standardized. This brings back to the question of including handle-based metadata. So what is in the PID and what is in the metadata fields are well defined somehow. And this is the concept of the typing, data typing, and the concept of PID types and data types. So in order to make, to be able to make these database queries, there are unfortunately quite a great number of query languages. We won't go into the details. I just put these slides. The next slide is about the different interfaces and how you can implement with different technologies, different PID graph concepts. If you are interested, the slide is in the slide deck. You can go into details there. Coming to this side, here's a slide to really just introduce this topic and show how PID types and the PID record with types could look like. I'm not sure whether you see the details. On the screenshot, what you could see and what you will see if you download the presentation is that also the metadata fields, so the particular fields, what we used previously as title, as description, as URL, are also referenced by a persistent identifier. An example I always like to take is the author. Some information system stores the name of an author as just a complete string. Others divide these authors in first name, last name. Again, there are publication systems where the list of authors is just a string, so you don't precisely know which string belongs to which author. The idea of typing that kind of metadata fields is that you can have an exact description how your author field looks like. So whether it is a list of author records, whether it is a list of first name, last names, or whether you have your own fancy definition for it. The main idea is that you clearly machine actionable describe your field and you create in a type registry a PID for this description, and you share the PID of this description across all the systems which are processing scientific data.
So you have a registry for data types, right?
Yeah.
This is the registry of data types, and in our example, in the hands-on, instead of writing URL, description, title, we should have created a type in the data type registry and use the persistent identifier instead of using title, description, and URL. Only the URL is the same, right?
So basically this is a three-step process. So let me go and show an example. This is there are different services how to register and describe type definitions. This one is a screenshot of the service probably being provided as B2 type in the future, Currently it is provided by the PID consortium as a type registry. It is able to register a very exact and precise description of the fields. What you need to know here is that at the end, when you did this, you will get a PID, a persistent identifier to this description, and you can share this PID in the metadata description, which is the second step. So, can you? Yeah, this one. Instead of using things like file size or other strings,
Responsible checksum.
you can use the exact PID to the description, to the definition of that particular field. Here is also different ways how to create the record. On the right side, this is the most precise but most complex way of doing it. On the left side, you can create so-called PID profiles, where you say in the profile the particular fields are used, and these are, if I say author and say this is a PID profile, this is my PID profile, then in the profile it is described and linked which exact description is valid for which fields. Again, this is...
question. So
yeah.
This PID profile, are defining a profile for the type of PID so that people can register different PIDs based on this profile? Or it is a profile for a specific PID which points to a specific data?
Yeah, let me put this in a context. So there is one World Data organization called Research Data Alliance.
Yeah.
There was a working group on persistent information types, persistent identifier types, and kernel information profiles. They had an idea and a description how to do this technically. So what is the basic idea to typing that kind of PIDs? Now with the emerging Fair Digital Objects Forum, people started to speak about fair digital objects. And at the end, if you just have a PID points to a fair digital object, you can put the type of these fair digital objects directly in the PID record. So this is somehow typing the fair digital objects. And if you would like to know more, then I would like to point you to the RDA, to the two RDA working groups, and to the Fair Digital Objects Forum specifications.
We can all use the same types, right?
Yeah.
We can create group of types, right?
Mhm.
And follow this group for persistent identifier. And that's why these services are available, because you want sometimes to create your own schema, let's say, to have a record with common types. So you use the data type registry.
Because I see this, the graphs also are very similar to the ontologies and the vocabularies of data modeling in here. So
Yes.
I'm not sure if they are doing the same thing. So is a graph doing
Connection,
same job as a
interlinks.
data
Huh?
schema and ontology for?
The basic idea behind the graphs, graphs are kind of a concept to do network analysis easily and to identify relationship between thingies. This is not the only concept, how to identify and describe relationships between entities. But this is one where the graph technology can be used. So
It's like the example, you can create graph for the authors and the publications they have, right? The funding, the organizations, the same, right? You put the information and just you use the graph technology to visualize the connection, the links between the different types of persistent identifiers.
yeah. So let me jump back to these 3 steps. The first step was to somehow describe what you want to describe and get an ID, a unique ID for this description. The second is that use this unique ID for the descriptions in the metadata fields. And if you did this, then on the third step, you will be able to use that kind of well-specified metadata information in services. So this is, of course, community acceptance. You need to speak with other people. You need to share your definitions. And at the end, you will be able, on a machine actionable way, provide that kind of, or use that kind of metadata, what you have in your basic handles. I have 2 short slides on practical questions. More on practical experiences and open questions, which is usually a nice way to somehow open the discussion. So here are a few topics that are discussed quite often in the context of PIDs. One area is the semantics in the PID, in the semantics of the PID string itself. So what Temis was creating is a string saying summer school. What machines like is a bit less semantics, because this summer school can be held next time in winter because of the next COVID wave, or I don't know. So semantics can always change.
I'm not used with machines, I'm used with people. So
yeah. So the discussion point is if you use just dump identifiers, if you use randomly generated strings, is it good or is it bad? And of course, typing summer school is much easier than typing such a long string. And especially if you type a long string, then the likelihood of human error is quite high. Another discussion is around the landing page. So when you resolve the PID, where you should end up? Should you end up on a landing page which shows the metadata about your scientific article, or shows metadata about your dataset? Or should the PID bring you directly to the dataset or to the article, so you can start reading the article directly? You can download with the PID the article and not seeing the landing page first. There is no good and bad answer. There are just different concepts how to deal with it.
But most of the services support both of
Yeah.
So the first step is to redirect to a landing page, and then when you want to request the resource, they have an API that you can directly ask for the resource so as to use it for in your system.
So the most of the technologies we presented today, and most of the organizations we described today, support different concepts. You just need to understand which one fits the best for your particular use case.
But they support different ways, but they behind the scenes, in their technology part, they support the landing page, the resource, directly to get the resource and all these different actions. But when you read about them, they propose different things. Some of them propose to go directly to the landing page, others not. You have to read about them.
Yeah.
Decide which one to use.
Another area is the granularity of PIDs. So there will be a point in time, if you deal with PIDs, you need to decide what gets a PID. In Göttingen, a university library scans books. So there are lots of books and lots of images at the end. And the question is, what should get a PID? Should the book get an own PID? Or should every single page, every single image gets a PID? Or even, there are researchers, digital humanists and linguists who deal with particular parts of a page, a kind of a paragraph. They would like to cite a paragraph. Should every paragraph get a PID? Interesting question. Again, the technologies support so-called fragments in objects. The technology is there to support this. You just need to understand how to deal with the granularity of your PIDs.
It was assigning persistent identifiers to a video, and every second of the video. So you had 10 minutes video, and for each second of the video you had a persistent identifier, because they wanted to get and not read how. They use them at the product, the scene, and trying to add more information, understand what's going on, to compute and find results for each scene of the video.
Yeah. If you would like to reference just a part of a video, you don't want to send the PID around for the whole video, because you just want to point and reference this fragment of the video file. Another topic is the metadata in the PID. How much metadata should you put in the PID? Should the PID record be almost empty and use a dedicated external service for managing the metadata? This is the way how DataSite, for example, works. The DataSite PIDs are almost empty. The only thing which is in the DataSite PID is just a pointer to the landing page in another system where DataSite store is the metadata. In the case of EPIC, the EPIC PIDs are enriched with metadata. How to describe the metadata, I showed you in the previous slides. Very interesting question is the lifetime of data and lifetime of the PIDs. So what happens to the PID when the object is deleted? Göksenin showed examples and happily deleted the PID without worrying about having a shared and published PID somewhere else. So best practice says, depending on the policy of your PID provider, the best practice says PID stays. Object can be deleted, but in the PID you need to put some extra information. This object has been deleted at that day. So if someone later in the future resolves the PID and cannot end up at the digital object, then he or she still has the information. There was a PID, there is a PID, there was an object, but it was deleted that time. Or other way around, it might happen in the future. For example, if you submit a scientific article to a journal, you might have a PID, you might have a DOI earlier. The object itself, the article itself is not published, but the publisher assigns a PID a bit earlier. Owners of PIDs. So who is the owner of the PID? Is it you who owns the PID? Is it your institute who owns the PID? Is it someone else who owns the PID? Is it the same like the data object? Interesting question. And the favorite question is, and with that you can basically kill any of your meetings when you start to discuss what the object is and what the digital object is. Is it just a digital representation of something? So is it just a digital representation of your article? Or is the digital object the article itself? Depends on the concept. I won't go into the details of the next slides. Probably just showing how the EUDAT services use PIDs. This is B2Share. So yeah, B2Share is sharing sharing data, any kind of data objects with others. B2Share, when you upload something in B2Share, it assigns a PID to the data objects. B2Share supports handle-based PIDs, so B2 handle, and it also supports DOIs. The question is, who pays at the end for the DOIs? Next service is B2Find. Thank you. B2Find is somehow trying to deal with that kind of issues, that kind of problematic. So B2Find tries to collect objects and information from different sources and presents this and links together. So B2Find is now able to if you check a community, if you check instrument IDs, you will see related data sets. That kind of linking exists. And I've already mentioned this, won't go into the details. If you would like to assign PIDs for instruments, it's also possible in the EUDAT context. if you would like to see more, Göksenin is happy to give you a live demo how to assign instrument IDs. And with that, I think we can officially close and officially finish the presentation. We prepared a nice or not so nice game. I wouldn't name it exercise, but it's a list of 20 questions around PIDs. If you are interested, one of us will post the link into the chat, and we invite you to play a bit with this game and try to answer as many questions you can. With that, I think we all thank for you to attending this session. I hope you bring home something new about persistent identifiers, and that's the main message, that you understood a bit in which area of your scientific workloads and which area of your everyday life you can use persistent identifiers. So thank you.